Outlier. My name is Kate Miller, and this is my lightning talk. I am a social scientist and a biostatistician, and for over 20 years I've worked with clinical research teams from many fields of medicine to design studies and publish the results. I use data visualization every single day in my working life. I think of myself as a scientist who's also like half of a designer. From this particular perch, I've had a good long view of data visualization practices across the medical literature. And I see a few pros and cons. Starting with the pros, medical journals have very clearly defined audiences. So when you're designing a figure, you have this luxury of knowing exactly who your readers are going to be. You don't have to guess at your audience. Also, these readers tend to be highly trained and often quite technical, so they're used to spending a little time reading a figure. It's more than just a glance. So you sort of have this freedom to present some depth and complexity to the visualization. Also, there's a shared visual vocabulary very clearly across all medical journals. You can always present bars and histograms and lines and scatters with no problems. Most medical fields are also quite comfortable with forest plots for ratios with confidence intervals and also Kaplan-Meier survival curves, which is a specific type of line graph. So moving on to the cons, the first con is that same shared visual vocabulary, which I just said was a pro. The vocabulary is actually quite narrow. Once while working with a team of palliative care physicians, I made this swimmer's plot, and it blew their minds. They loved it. Now I'm working with a team of oncologists, and swimmer's plots are boring, old news. They've seen them all the time. Meanwhile, to the oncologists, this sand key I made of our results was totally novel and exciting to them. So the conventions can also be quite narrow and quite siloed. The other problem is that the conventions sometimes just are badly designed, in my view. There's a very common type of figure in a medical journal, which is a multi-panel like this. This one has no less than 11 panels, and the information needed to read the panels is buried in this lengthy, small text figure legend down here. These kinds of figures are quite common and sometimes even required by the journal. In fact, this figure is the example that this particular journal gives to submitting authors as a template. So in that case, I feel that you're required by the journal to make a design choice that I would call very cognitively inefficient. As a whole, most medical journals are quite resistant to change in figure design. There are some excellent counterexamples, vibrant journals that are really pushing this, but overall I think the peer review process is inherently conservative. Every single time that I submit a manuscript for publication, I try to push the visuals just a little bit. Let's try this in this journal and see if we get away with it. Sometimes they get published, which is a small victory, but often a reviewer will be unfamiliar and say, take it out. I think about how newsrooms are so dynamic and vital now in data visualization. They have these huge graphics departments and they really innovate, and I am jealous. Medical journals on the whole just don't have that same culture of change. In conclusion, I'd love to say that these clinical researchers that I work with are smart, good humans. They practice medicine and they do clinical research, and Lord knows they don't need anyone telling them that they have to become experts also in data visualization. Rather, there are people like me who try to provide that expertise. From my experience doing this, I believe that the strongest contribution design thinking can make is with the principle of effectiveness in visualization, which I think of as mapping the most important content to the most salient visual channel. The good news is that every study has to identify its most important content up front. This is called the primary aim or endpoint of a study, and there can also be secondary aims or endpoints. So there's this baked in, pre-specified hierarchy of importance of the information coming out of the study. I think where people struggle is knowing how to encode that hierarchy in visual channels in a figure. So that's where I think data visualization designers could really add something to the medical literature. Thanks so much for listening. Here's my email. I'd love to hear from you. Bye.
Question for you. I was wondering what prevents the adoption of good design in medical journals? What do you think can help change the view of medical journals to move towards adopting better design principles?
Oh my God, it's such a good question. And I think about this all the time. Like I said in the talk, I think medical journals in general are quite resistant to change in this way. And there's like institutional reasons for that going back to like the 18th century or whatever. But I think part of it is that actually when you're carrying out the scientific method, you do need to have really strong guardrails. And I think that some of those rules that they have for figures are about trying to guard against bias. You can't just make any figure you want because you don't want people having to tease out like, is this a biased figure or not? We just get everybody on the same like column graph and then we're clear where we are. So there's this tension between novelty versus protecting against bias in the scientific research. But I think there's still plenty of room to move. That's my view.
For sure. And I think that kind of leads into this next question. Do you think some of the resistance to new visual techniques stems from suspicion that an unfamiliar chart is trying to mislead or misinform?
Huh. Maybe, maybe. I guess I'm thinking back to times when I put in maybe a more unusual chart and then the reviewer comes back and has a problem with it. I've never seen a chart like this before. Um, I think it's more like not being able to interpret it correctly. Oh, this is a sand key. Like I don't know how this is relating to your results. It's like just not computing. So then they see it as unclear, which I get. I have to spend time with a new chart type. I get that.
Yeah, absolutely. And incremental changes.
That's right. That's right. That's what I mean. Like, just push it a little bit. Just try to push the field. Yeah. It's my one woman campaign I've been on for 20 years. It's not working. Oh, I can't hear you.
Oh, sorry. I'm curious too. So you talked a little bit about the ways that you've kind of pushed them. Are there ways that you've kind of also learned a little bit more from the medical community about how to do, like, is there something as particular chart type that you've kind of been like, yeah, you know what, that was correct. Like, I would have gone a different way with that. You know what I mean? Like a little bit of reverse learning. You could say no.
There's tons of reverse learning. Well, for example, I do think that the chart type is pretty tied to the subfield. For example, there's a whole class of visualizations in genetics research that I don't understand. I mean, I can't even read the figures. And I would love to be able to read the figures because geneticists do, obviously, because they're in the journals. And I think I have a lot to learn from that. It's because the underlying data set is so different than the kinds of data sets I'm usually looking at. So yeah, I definitely do learn. And you learn a lot about the readership, obviously, and what they're used to and what they want to digest. So it's fun.
Well, please don't forget to go to the chat and see all the love you're getting. A lot of people.
Oh, that makes me happy. Well, thank you so much for the opportunity. I really appreciate it.
That's excellent. Thank you so much. All right.
Okay. Bye.